type of current you see, that will be ampere only. Don't say electromotive force is there, Newton. Okay, it is not Newton, it is the voltage, electromotive force. Fine. So here we have option A, B, C and D. A is 0, B is 15 microampere and 10 microampere, and option D 5 microampere. Okay, so here we need to find out the displacement current. So that what is the relationship? Here directly we cannot find it, right? Because we do not have mu naught. Mu naught, we can write it. Okay, what is mu naught? Mu naught divided by 4 pi is equal to 10 power minus 7 value we have. What about d phi? We do not have any change in flux. Rate of change of flux we do not have. We cannot find it out. Displacement current. So that is the reason there is a one common relationship between conduction current as well as displacement current by the concept. So here can I write conduction current is equal to displacement current? Okay, so where this conduction current is given by the definition dq by dt. Am I right? What is this dq by dt indicates? What is this dq by dt indicates? Flow of charges or rate of flow of charges? Rate of flow of charges. So by capacitor and capacitance we have a relation Q is equal to CV. What is this C? V, voltage. Okay, so I'll substitute it. So now ID is equal to IC. Am I right? Now IC value we have D divided by dt. In place of a Q, I'll be substituting C into V. Right? So capacitor value is same. It do not change. So I'll take it out. C dV by dt. So now we can find out a displacement current by substituting the values. What about C? 1 microfarad. Okay, 1 into 10 power minus 6. Why I'm writing 10 power minus 6? Because we have to express in a SI unit itself while solving the numericals. Okay, now into what about dV by dt? 5. Just a 5. Is it in SI unit? Yes, volt per second. SI unit. So 5 into 1, 5 into 10 power minus 6 ampere. But in the option you can see there is no 5 into 10 power minus 6 ampere. But instead of that they have used sub-multiple concept, that is a 10 power minus 6. We call it as a micro. Okay, so for that, so ID is equal to 5 microampere. So this is your required solution. Hence option D is your right answer. Got it? Okay, please copy this. Finished? Okay. It is a dt, not a dl. Now next question. Try to solve by your own. Okay. Let's see how many of you are able to solve it. Question is, a capacitor has been charged by a DC source. A capacitor has been charged by a DC source, full stop. What are the magnitude of conduction and displacement current? What are the magnitude of conduction and displacement current? Here you need to find out IC and ID. Okay. What are the magnitude of conduction and displacement current when it is fully charged? The condition they have given, fully charged. So here options are And you have to know the reason also. Okay. Now tell me which option is right, and also give me the reason.
D.
Option
D.
D. Are you sure? Fully charged.
Yes, sir.
Sir, I see
Ah. Which one? Option
B.
B. Option B is right. Why? Can you give me the reason? Because IC is equal to ID. When it is a fully charged, right? When it is fully charged, what happens to the electric field?
Rate of change of electric flux.
Yes, rate of change of electric field
Flux.
will be, field will be 0, means that indicates rate of flux, electric flux will be 0.
Field will be there, sir. Rate of change of electric flux will be 0.
These are the plates. Okay, so here if you want a displacement current, there should be a electric field. Okay, that too change in electric field. Okay, that change in electric field lines linked with these capacitor, generally we call it as a flux. What kind of flux? Electric flux. If it is changing, then only you can see displacement current. If it is fully charged, as he said, electric field will be there, but what happens to the rate of electric flux?
Will be 0.
Will be 0. If rate of electric flux is 0, are you able to see this ID?
No, sir.
So this will become 0. If it is 0, according to the relation, conduction current and displacement current, that will become 0. Both are equal, right? Okay, so this is how you have to know the reason also. Got it? So next question, copied. Along with options, you have to copy it. Next question. So this question consists of both previous concept and present concept. If you remember previous concept, that is EMI, electromagnetic induction, that is impedance concept. You can do it easily. Okay, so let's see question number 3. Question number 3. Question number 3. A 100 ohm resistance and a capacitor of 100 ohm, a 100 ohm resistance and a capacitor of 100 ohm reactance, a capacitor of 100 ohm reactance, not capacitor, okay, reactance. It should be Faraday, you'll be thinking, right? It is not. Reactance. Okay. XC, XL, XC, XR, you all learned, right? Reactants are connected in series. What is the circuit here? LCR or LR or CR?
LC circuit.
Okay. R is there, no? RC. Reactance, resistance there, RC circuit. Okay, are connected in a series across 220 volt source. 220 volt source. What is this 220 volt source? Is it a root mean square EMF or just voltage? Yes, because we are using AC. Okay, 220 volt source. Full stop. When the capacitor is 50% charged, it is not completely 50% charged. Therefore, what happens to the rate of electric flux? Will be there or will be 0? Will be there. Okay. When the capacitor is 50% charged, the peak value of displacement current is peak value of displacement current is peak value of displacement current is. So, can you tell me what are the data they have given? Okay, options. First tell me the data. Resistance. Resistance they have given. How much? 100 ohm. And what about next one? XC they have given. 100 ohm. It is not XL. XC. Okay. XC. And what about VRMS? How much? 220 volt. And what do you need to find out? Displacement current. Option A, 11 root 2. Option B, 2.2 ampere and ampere. Option C, 11A. Option D, 4.4 ampere. Now what will you do? Which concept you will be using? ID means it should be epsilon naught d phi by dt. Do we have any rate of change of flux, electric flux? No. Right, we cannot do it using epsilon naught d phi by dt. But we have one more relation. What is that? Conduction current is equal to displacement current. Conduction current is nothing but, we already learned, EMI. Conduction current, that is nothing but IRMS, right? IRMS, root mean square current. Have you learned? What is that formula is given by? IRMS is equal to square root of I naught divided by root 2, no? So I naught divided by root 2. What about I naught?
Peak value.
Peak value. Okay, how do you calculate peak value? How do you calculate peak value? V naught divided by Z. Do you remember? V naught divided by Z. What is that V naught? 220. Right. VRMS nothing but. So here I naught is equal to, what is that? V naught divided by Z. Am I right? What is this? Z indicates impedance. This impedance is given by R square plus XC whole square. What is this? R 100 plus 100 square. So this will be giving 1 followed by 4 zeros plus 1 followed by 4 zeros. Am I right? Can I write it as a 2 times 1 followed by 4 zeros? Okay, now if I take it out this part, what I'll get? If we take out 100, it will be 10. If we take out 10,000, it will be 100. You know, right? Under square root. Okay. So this will be 100 root 2. So this is Z, impedance. Okay. Now, substitute here. How much you'll get? V naught. How much? I naught is equal to 220 divided by 100 into root 2. Correct? So 1010 get cancelled. So here 2.2 divided by root 2. Am I right? Because 22 by 10, it is given by 2.2 divided by root 2. It is I naught. Now what is the final? I naught. How much you will get? Okay, this is I naught under square root 2. So IRMS, that is equal to which one? So I naught is 2.2 under square root 2. This one? Root 2. Is it correct? No, something went wrong.